Hi, this is Victor Morganti from FactEngine. I'd like to speak with you about the FactEngine Advantage and where FactEngine leads the world in what will come to be known as the semantic view of data warehouses and data lakes, etc., as opposed to the semantic layer, which is technology that we support, but where FactEngine provides a semantic view which adds just so much more value than simply a semantic layer. In order to introduce you to the semantic view, I want to talk about a fictitious company that we've made up just for the purposes of this video, and that's the Nolana Health Alliance. It's a large health alliance company, and where Nolana needs data warehousing and data lake solutions, and being able to abstract away from how data is normally stored in a very terse format within various databases. So we've made up Nolana for the purposes of this video, and let's see where Nolana is struggling at the moment. As a large healthcare organisation, the business is broken up into at least 8 primary areas, and at least from the perspective of the sorts of data that we want to store in our data warehouse and data lake. We have electronic health records, claims and billing, clinical decision support system information, health information exchange, where Nolana exchanges information with other healthcare providers, research and analytics on the data stored within the data warehouse or the data lake, pharmacy management, where Nolana runs a few pharmacies, human resource management information, and financial management information. So we can see, as a large healthcare provider, Nolana really has its work cut out for it from the get-go, because it's got lots of systems and lots of disparate data that it needs to amalgamate within a data warehouse or a data lake to be able to serve up to its customers, so the consumers of that data, to be able to do business intelligence, reporting, etc. on that data. Now, typically within a data warehouse scenario, we have various operational databases pictured here on the left hand side. So for our various business areas, for example, having their own discrete databases, and where we extract, transform and load into a centralized data warehouse, and where various OLAP servers and cubes operate over the data in the data warehouse to be consumed by clients using business analytics tools or business intelligence tools. Depending on the size of your organisation, this type of architecture is quite well and good. There's nothing wrong with this architecture at all. And FactEngine will support any database that we can get a connector to, and we have no preference for any sort of architecture or data warehouse or database type. What's very interesting in the space, though, today is that in this central area here, there's a multitude of options to choose from, and where you might have a virtual database where you effectively virtualize these operational databases into a centralized repository or a virtual semantic layer. Or you might have a physical database which virtualizes one or more other databases, and where the lines get pretty blurry, and to be honest, where customers don't really care because all they want is access to the data, and they want it in the most quick and convenient way they can get, and with the minimal amount of fuss in terms of understanding the data in the first place. So understanding what all the key terms and business rules are that are within that data. So if we look at some databases and those that are supported by FactEngine, this is just a very small view over the range of databases available, and for data warehousing and creating data lakes, all depending on the size of your organisation. Some attribution first. We're using these logos under the fair use legislation. So for instance, Microsoft SQL Server, you can have physically implemented on site on a server or hosted up in the cloud, and where Microsoft SQL Server might not be just its own database, but might virtualize one or more other databases as well and make those available to a client. Might be a bit of a stretch to think that anyone would ever use Microsoft Access, but certainly SQLite has been used for data warehousing. The types of solutions that I find the most interesting and that are going to support our Nalana data warehouse at a large scale are technologies such as Presto and AtScale and even Hadoop, where technologies such as Presto and AtScale provide a virtualized view over data sources, providing what, at least in the instance of AtScale, what is known as a semantic layer, and where business concepts are coalesced into their most simple form such that business users can understand them. What we're also seeing in the database space at the moment is where more and more features are being pressed into the database space rather than at the client side. So more in the data warehouse rather than with the clients, where consumers want to do things like machine learning over large data sets, and where that might be best served in the cloud as close to the data source as possible, and where the types of compute that are required for machine learning exercises are better served with the type of servers you can engage with up in the cloud. So what we're seeing with technologies, and this is just not to pick on these particular databases, but as an example, so Presto, AtScale, Hadoop, these technologies, one way or the other, are either virtualized or as copies of actual data, will take siloed and disparate operational databases and present them to the consumer or to the client or to the customer as a centralized view one way or the other, and where the idea, for instance, with AtScale as opposed to, say, Presto, is that it's presented as a semantic layer, specifically not just in terms of marketing and product positioning, but as a core value of being able to provide a business centralized view of data, and where technologies such as Hadoop also centralize data but offer capabilities that streamline machine learning processes, etc. So we're taking satellite siloed operational databases and presenting to consumers a unified view of that data. Because we're talking about a semantic view, I will talk about at scale, because at scale presents their offering as a semantic layer. And if we look at a semantic layer definition, say from Wikipedia, we can get a feel for where the industry is at with the terminology and conceptualization of what a semantic layer is. So it reads here: a semantic layer is a business representation of corporate data that helps end users access data autonomously using common business terms managed through business semantics management. A semantic layer maps complex data into familiar business terms such as product, customer, or revenue to offer a unified and consolidated view of data across the organisation. So far so good, that's what customers want. By using common business terms rather than data language to access, manipulate and organise information, a semantic layer simplifies the complexity of business data. Business terms are stored as objects in a semantic layer which are accessed through business views. Now here's where we start to get technical even in the terminology. Business terms are stored as objects. If I'm working in finance in a large healthcare organisation, I'm not going to care if something's stored as an object or not. I want to talk about bank accounts, I want to talk about loans, I want to talk about revenue and budgets. I don't care how it's stored within the database. So even with the crowdsourced definition of what a semantic layer is, we start to hold on to the notion of the technical aspects of a semantic layer. It goes on to read: the semantic layer enables business users to have a common look and feel when accessing and analysing data stored in relational databases and OLAP cubes. This is claimed to be core business intelligence technology that frees users from IT while ensuring correct results. That all sounds good. Business Views is a multi-tier system that is designed to enable companies to build comprehensive and specific business objects that help to report designers and end users access the information they require. Business Views is intended to enable people to add the necessary business context to their data islands and link them into a single organised business view of their organisation. Semantic Layer maps tables to classes and rows to objects. And there we are again. We don't care about tables and classes, rows and objects. We care about customers and sales, bank accounts, revenue, budgets. We're not the slightest bit interested in tables, classes, rows and objects. So with our crowdsourced definition of a semantic layer, we're still holding on to the notions of tables and classes, so the technical side of the ability to deliver data to customers. Now the term semantic layer has been around for some time. If you do your research on the internet, it's well over 20 years, probably close to 40 years people have been using the term semantic layer. So it's been around for a long time, and to be honest, there's going to be some sort of association with the physical layer, especially when the technologies that are making the ability to provide true semantics is just coming into the fore now in the IT industry, and where semantics is on everybody's lips, and it really is a 21st century phenomena where technologies such as large language models, for instance, bring natural language and natural language querying and natural language interfaces with computer systems, but also data to the mainstream. So we really want to ask ourselves, is a semantic layer, does it equal entity relationship diagrams? Does it equal tables and rows and things like that? No, it doesn't. So we might have a business type view within our entity relationship diagrams. For instance, here, providers and people, and visit occurrence and visit details and care sites, for instance, for our healthcare organisation. But from a consumer point of view, from a customer point of view, so someone doing business intelligence in finance, or a doctor who has access to the data warehouse who's doing research, or someone in the pharmacy who needs to do an ad hoc query against orders made for medication on a particular date. They're going to be least interested in a entity relationship diagram, or in the modern day, property graph schemas, where semantic layers as they stand today provide this sort of interface to a data warehouse or a data lake, and where entity relationship diagrams and property graph schemas are very helpful. Let's not get that wrong. But when we talk about a semantic view, as will become more prevalent in the industry, we want to be talking about natural language business rules, natural language terms and vocabulary, and how they tie together with a semantic layer. So a semantic view over a semantic layer. So let's have a look at what a semantic view will come to look like. We can imagine for our Nolana healthcare organisation, our semantic view really encompasses semantics, where we're talking about a business vocabulary and business rules, and where we can have a glossary, and where if I want to know information about a claim, so claims are quite prevalent in the healthcare industry, we have a list of business rules in natural business language that can be read by business analysts and data analysts and business intelligence experts who want to be able to query the data based on the knowledge they glean about the data from a semantic view over the data warehouse or data lake. So let's read through some of those. So a claim possibly has more than one adjustment. So you can make an adjustment against a claim. Adjustment is against at most one claim. So that's a business rule in natural business language. Claim has at most one claim amount, and a claim amount possibly has more than one claim. So for instance, you might have a claim amount of $100, but $100 isn't exclusive to one claim. You can have multiple claims that are for $100. Claim has at most one claim date, and the claim date possibly has more than one claim. So you start to get the picture where looking at the data in our data warehouse or data lake in a brand new way. We're looking at it with a business vocabulary and business rules that business people can read in natural language. Now you might say, well, you know, if I look at a entity relationship diagram, I can glean that kind of information. Well, you might be able to if you can read entity relationship diagrams or property graph schema. But just about anyone in business can read natural language and business rules in natural language and understand a business vocabulary. So what do we want then in a semantic view? Well, we can still have our semantic layers. So FactEngine's very quick to say that we'll do business with companies like AtScale. We'll work with anyone who works with Presto or Hadoop or SQL Server or Oracle, or any database for that matter. We still want this semantic layer because it is helpful in terms of being able to provide a whole suite of benefits to customers in terms of amalgamating data into centralized views, or being able to provide services for machine learning and deep learning, etc. But what we also want is a semantic view over the top of our semantic layer, where we can look at the content of our data warehouse in natural business language and with a vocabulary that reads like a dictionary. And that'll be our semantic view. So FactEngine is in the business of providing a semantic view over the top of any database or data warehouse we can connect to, and where we can do that in the cloud or on the desktop. So let's have a look at how FactEngine does that. This is Boston, which is one of FactEngine's two key products. And Boston is a conceptual modeling tool which can be used as a semantic view over your data warehouse or your data lake, and as a productivity tool, and as a business intelligence query tool, and as a enterprise class conceptual modeling tool for enterprise models. We've got a model open in the Model Explorer in Boston, and it's the healthcare Nolana model, so it's the model or the schema for our Nolana data warehouse or data lake. And if we right click on it, we can go straight to the glossary view, and we can find, say, claim, and start to look at the business rules that relate to a claim in our universal discourse, our enterprise, Nolana. So I'm just going to hide the light and fact types that were shown there, so we get a cleaner view of this particular view over our data warehouse. The glossary view lets you navigate through your semantic model, where if I'm reading and I see claim possibly has more than one adjustment, and I want to find more information about adjustment, I can just click on, say, adjustment. That'll be selected in our vocabulary. The business rules that relate to adjustment are brought up onto the screen. So for instance, adjustment has at most one adjustment code, and adjustment code possibly has more than one adjustment, for example. If we want a conceptual model as a graphical diagram of our schema, we can view that as drawn automatically for us within our glossary as a way to further enhance our ability to comprehend the model by having a graphical representation of the model as well. And that's in object role modeling, and it's object role modeling that provides the semantic information to be able to produce our natural language business rules, and where object role modeling, which is a type of fact-based modeling, is arguably the most semantically verbose conceptual modeling language in the world. If we look at, say, something like adjustment amount, we have excuse me, an extra form down here, or toolbox, which provides an object role modeling verbalization, which will give us even more information, and it'll tell us some of the technical data if we're interested in that. That adjustment amount is a value type, and its data type is a excuse me, text variable length. So we have a business vocabulary, we have business rules in natural language, and we have diagrams to help us understand the model. We can also set up pages in other languages if we want to see our data model or our conceptual model or our semantic model as a graphical model. So for instance, this is one of the areas of our data warehouse, so our electronic healthcare records section of our data warehouse, and where we're talking about people and providers and appointments and lab results and medication and diagnosis, medical histories, conditions, condition occurrences and condition types. If we really desire, and it's going to help us to write our BI, our business intelligence queries against the database, we can look at all the various or the business objects that we read about in the Wikipedia page, and where what we're looking at here is a property graph schema for a graph database, and where we can see the properties of various node types by control clicking and seeing the various properties, as they're called for a property graph schema, of say person, so the year of birth, their first name, middle name, last name, etc. Our data warehouse has got quite a few node types or tables. It's got 95, and this particular data model has been based on the OMOP model for healthcare. So it talks about adjustments and appointments and budgets and costs, diagnosis and devices, drug exposures, etc. So it's a healthcare data model or conceptual model, and we're looking at one particular view of it, which is the property graph schema view. But Boston lets you view any database as if it is a multi-model database. So if we want to, we can view our conceptual schema or our semantic layer as a entity relationship diagram. That's quite involved and it's a bit out of scope of this video, but what we're saying is that regardless of the technology of your data warehouse, whether it's a graph database or a relational database or even a hierarchical database or a key value store, Boston lets you conceptualize your data warehouse as if it were a multi-model database, and where we could say look at claim and its related entities or objects as a entity relationship diagram or a property graph schema. And this is technology which is highly pronounced with FactEngine and is quite unique to the FactEngine offering in Boston. The relationships between key business terms in our semantic layer become important when we want to do business intelligence queries against our data warehouse or data lake, and that's where FactEngine comes in. So if I right click on my model and open FactEngine, we now have a business intelligence tool where we can write natural language queries, and I've got one saved in my clipboard here, where we can ask questions such as which payer has a claim that was made by the person Simon Love and is against the provider Kathy Snelling, Now you'll notice that's in almost natural language. It's in controlled natural language, and it's called FactEngine query language, and it's made possible because of the level of semantic information stored within an object role model, which is the basis for providing the various views of our semantic view inside Boston and FactEngine. So the FactEngine query language is a graph query language. It's a structured query language, and it has a mapping to either SQL or Cipher for a graph database, or Type QL for a TypeDB database. And where FactEngine can make a connector to query just about any database using FactEngine query language. So let's execute that query, and we can see these various payers here, so Blue Cross, Aetna, Cigna, United Healthcare, etc. have a claim that was made by the person Simon Love and against the provider Kathy Snelling. The ability to write queries in FactEngine is made easy because we have our semantic information in our meta model. We can use IntelliSense, where we can say get prompts to help us complete our query. So we're going to say that the claim was made by a person, Simon Love, and where that claim was against the provider, and we've got a drop down list of providers here, and we were using Kathy Snelling in our example. So that's gone out to the database and found the appropriate data for us to be able to use, and I should be able to run that query again and get our results. So FactEngine has a IntelliSense-like helper which helps you write the queries as you write them in controlled natural language, using the semantic information that's provided by using object role modeling, and sticking with our semantic view, where we have a very easy to read business intelligence query, rather than writing this is the SQL for that query against a SQL database. So it's much easier to write ad hoc queries and business intelligence queries using FactEngine query language, where it automatically gets converted to the database language of your choice, so that you don't have to write SQL. You can still write SQL. I mean, you could write SQL in this this text box here and hit go and get your results. So you have a choice, and FactEngine is all about choice. So you've got a choice of the database you want to use. You have a choice of the semantic layer that you want to use. You have a choice of the query language that you want to use. And we call that the FactEngine Advantage. So let me give you an example of that. So this is just one model in Boston. You can have as many models, and I've had up to 200 models in an instance of Boston. And where we've got another model against this time a graph database, so the famous Northwind database from Microsoft in a Neo4j database. And I've already got that loaded up, and where even though we're looking at a Neo4j database, we can view the database as a entity relationship diagram, or classically as a property graph schema. Now I can open FactEngine and write a query against that database. This time I'm going to use a feature in FactEngine where we're going to write the query in absolute natural language, and where FactEngine engages a large language model to convert that to FactEngine query language. So we're stressing here that our semantic view lets us use natural language to the maximum as a business user who wants access to data for their ad hoc queries, their business intelligence queries. So let's write a query just quickly in natural language. So we're going to say which employee took an order that was for a product that has a supplier that is based in the USA. Okay, so that's just in natural language. We're going to hit go on that, farm that out to a large language model, convert that to FactEngine query language, and there's our results. So these employees, so Robert King, Margaret Peacock, etc., took orders for products from a supplier based in the United States. So we've done our business intelligence query using natural language, made possible because we have a semantic view over our database or our data warehouse, where if I'm looking at employees in our Northwind database, we can actually see our business rule. Employee possibly has more than one order. Order was taken by at most one employee. And where we can extend our semantic view over our semantic layer by adding more predicates, so more natural business language as we need it. So we can say down here in the bottom here, order was taken by employee, but we can also say order has employee, or we can say employee has order, or employee took order. Normally we'd use employee took order. So we're adding value to our semantic layer by adding natural business language and a business vocabulary. And conceptual schemas in a property graph schema view, as if it were a graph database or a relational database. And we're adding huge chunks of value to our consumers of data by giving them the best possible means to be able to understand the data, to navigate the data, and to query the data in a business intelligent ad hoc query manner. Or we can write detailed SQL or Cipher queries in Boston and FactEngine. Now, if we look at, say, a particular entity or entity type or node type in our data warehouse, Boston is also a productivity tool where we can actually view and edit the data as if we were using something like a Microsoft Access database. And this form down the bottom here lets you actually edit data if you have permissions to against your database. So we have a productivity tool which not only lets you query your database, design your database or data warehouse, but actually view and edit data of your data warehouse or data lake as well, So it becomes a productivity tool not only for consumers, say in the finance department, or a business analyst or a pharmacy person writing ad hoc queries, but also where the people who maintain the data warehouse can use Boston to view and edit data within the data warehouse as well. You might say, that's all well and good, but we live in a age of the internet and cloud-based services. Is Boston and FactEngine available in the cloud? Well, the answer is yes. So let me take you there now. So here we're looking at Boston in my browser. So we're at boston.factengine.ai, and depending on the resolution of your screen, you'll see that I'm in a browser. That's my browser tab. I can click on the address bar, and if I hit F11 I can maximize the screen, and all of a sudden I'm using Boston in the cloud. And here I'm looking at the same database, this time in the cloud, and where I can open FactEngine and run our same queries and get our results in the cloud. So we can write business intelligence queries against a data warehouse from anywhere in the world. So if you've got the right credentials to be able to access Boston and FactEngine over the web, then you'll be able to access and query your data warehouse. Now, there is a permission-based database behind access to Boston over the web, where you can limit what people can do against the data warehouse, so that they can either edit it or just read only, or you can even limit what models they have access to. So this is just one model. If I minimize that, you can have multiple models as semantic views over the same data warehouse, and where you can grant permissions to write queries to a limited subset of all of the entities or node types within your data warehouse to specific users, such that user A can access, say, finance information, and user B can access claims information, for instance. So there are security controls over who has access to what. The beauty of putting Boston in the cloud as well is that knowledge engineers, business analysts, and database analysts, for instance, can work collaboratively to design the model, and where they can use various tools. They can use object role modeling or property graph schemas or entity relationship diagrams to construct the semantic view over your semantic layer. So where a typical semantic layer might just have a entity relationship diagram view, with the FactEngine Advantage you get the entity relationship diagram view, you get a property graph schema view, you get natural language queries or controlled natural language queries, and you get a business vocabulary and business rules in natural language, all as a semantic view over your semantic layer. This is the FactEngine Advantage. So let's talk about that. The FactEngine Advantage works like this. In terms of being able to get up and running, it's extremely fast to implement FactEngine and Boston. So you can self-host Boston. You can sign up to an account with FactEngine, or you can run desktop versions of Boston. We also have an API for FactEngine natural language queries over your data warehouse. It's extremely quick because you've already got a data warehouse or a data lake. You're just implementing a semantic view over your semantic layer or your strict data warehouse or data lake. It's a really intelligent solution because you're not throwing out the baby or the bathwater. You're keeping your sunk investment of possibly millions of dollars in the infrastructure and the database you've already got, and you're providing a semantic view over the top of your semantic layer or your data warehouse or your data lake. In terms of data governance, you get to keep all of the data governance processes and procedures that you have in place already, while getting the full advantage of the semantic view provided by FactEngine and Boston over the top of your data warehouse or your data lake. It's an extremely flexible solution because you have multiple ways of engaging with your data. So we've seen where you can have natural language business language queries. You can view your data, your semantic layer, as business rules in natural language. You have a business vocabulary. You can view your data warehouse as an entity relationship diagram, property graph scheme, or object role model. It's flexible because the outlay is just for FactEngine. You're not buying necessarily a whole suite of new hardware to replace your database or your data warehouse or your data lake. And you're certainly not having to replace your data warehouse or data lake. You get the semantic view, which you can just layer over the top of your semantic layer. You still get the microscopic view into your data, so you can run your business intelligence queries in your native language, so SQL or Cypher or TypeQL. But you also get the advantage of being able to write ad hoc business intelligence queries in controlled natural language, or even natural language if you hook up FactEngine to a large language model. And of course the cost savings are definitely there for you, because your investment, your time and energy that's gone into producing your data warehouse or your data lake is something that you get to keep and cherish and hold on to, and you don't have to retrain a whole lot of staff because you've provided a semantic view over the top of what you've already got. So together this is the FactEngine Advantage. Speed to market, a great idea. Keep your data governance. It's a very flexible solution. You get to query your data in ways that you haven't been able to before, and you're going to save a lot of money. So that's the semantic view. We have the ability to have a business vocabulary accompanied by natural language business rules and diagrams where we need them, so that consumers of the data and those who design the data warehouse and data lake have the best opportunity to understand the data they're working with. It's the natural language or the natural business language semantic view. We get to use graphical languages where we need to, so object role models, entity relationship diagrams, property graph schema. No matter what database you're using for your data warehouse or data lake, Boston and FactEngine will treat it as if it's a multi-model database. So we will treat it as if it's a graph database or an entity relationship, a relational database. It's entirely up to you how you use FactEngine. The query language is a controlled natural language query language, which is a graph query language that is structured and has a mapping to SQL or Cypher. It's not a random query language. It's a structured query language with construction rules that just happens to be very easy to read because it uses the predicates that are available in object role modeling to be able to write natural language queries. It provides a Rosetta Stone over your databases or your data warehouse or your data lake, because you might have multiple databases that you want to work with. So you might want to work with SQL for a relational database. You might want to work with Cypher for a graph database. You might want to use TypeQL for a TypeDB database. And to throw sugar on top, you might want to write your queries in natural language, farm them out to a large language model and have them converted to FactEngine query language to make your life that much easier to write business intelligence queries against your database. So let's recap on the FactEngine Advantage and the semantic view over your database using FactEngine and FactEngine's Boston software. Because your models are defined in the most semantically verbose conceptual modelling language available, object role modelling, which is a type of fact-based modelling, we get to write natural language business queries. We get to view our semantic layer as if it were a multi-model database, which in the 21st century is critical given the types of databases that are on the market, where many databases today support relational models and graph models within the same database. The natural business language semantic view gives you a business vocabulary and business rules in natural language, while offering the ability to have a desktop or cloud-based solution where you can have multiple models and user access controls over who has access to which models to be able to write which queries over the database or data warehouse or data lake. Our FactEngine advantage is that you're going to get product to market as quickly as possible. It's an intelligent solution to a difficult problem. You get to keep your data governance, processes and procedures. It's a very flexible solution which doesn't limit the way you query your database or your data warehouse or your data lake, but actually provides enhanced ways of doing business intelligence over your data warehouse or data lake. And you're going to save a lot of money. The semantic view doesn't compete with semantic layers. In fact, we want to do business with as many semantic layer providers as we possibly can. You have the option of a desktop-based solution, a cloud solution, and FactEngine is available as an API to do natural language queries over your data warehouse or your data lake. Your semantic layer, if you've got one, you get to keep it. We have our business vocabulary and our natural language business rules. A semantic layer is no longer just an entity relationship diagram. It's a whole suite of ways of looking at the data by having a semantic view over your semantic layer. We rewrite the definition of a semantic layer where we stop talking about tables and classes and rows and objects, and we focus more on business language as we move into the further into the 21st century. We get to play with people who are already in this business and who have ODBC connectors. So Presto's got an ODBC connector, AtScale does, Hadoop does. So you get to keep your technologies that you're using, and there's a whole suite of other providers in the semantic layer space. You get to keep your technologies for doing machine learning and reporting, but you get a business intelligence view using natural business language, which is going to help the business considerably. There's a whole suite of databases that FactEngine and Boston can operate over. Traditional models morph into something new where we're not just talking about a physical data warehouse or a data lake. We can talk about views over operational databases and information silos, and where whatever architecture you've got in place, FactEngine is going to be there for you. We found a very novel solution for our Nalana Health Alliance, where we found a solution where we could consolidate all of these, the views over all of these data silos into one model, or where we can have multiple models within a solution which has user access control over the ability for people to have the ability to query those areas of the data warehouse, and where analysts and engineers can view the semantics of our data silos in natural business language. And that's the FactEngine Advantage, and what will become known as the Semantic View as we move further into the 21st century. Thank you very much for watching. I hope you enjoy the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.